Okay, so today's problem is 22, number of ways to select buildings. So I read I've read and already started like solving it. The approach is the following. So for this problem we have buildings like 0 is like shop or like office, and like 1 is restaurant, and it's given as a string, a sequence of 1 and 0 characters, and I need to figure out what are the number of unique combinations, or like what are the number of combinations where like they have like 0, 1, 0, so no two types of buildings stand to each other in the combination. So the combination is 3 buildings. So basically they do the inspection. For the inspection they need to select 3 buildings, and they should be like no two types of buildings staying next to each other in the selection. So like here they selected 0, then 1, then 1 for the check, and this is not good option because 1 and 1 stay in the selection, stay close to each other, so it's like 0 and 1, so it's not the pattern of like 0 1 0 or like 1 0 1, because there are two consecutive buildings at the same time. Consecutive, they mean like in the selection of the buildings. So the question is how many valid ways to select 3 buildings exist there based on the input string s. So there, let's assume we have this input. Saved somewhere here. So the idea is to, pretty smart idea, to have this array of let's say number of zeros staying to the in a prefix. Let's say we wanna have s equal 0, that's 0 1 1 0 1. Some number of 0 staying to the right side of the I. As I equals 0 1 2 3 4 5. So number of zeros gonna be 1, then 2, then 2 stays, then here 2, then 3, then 3, and number of ones, zeros and ones, number of ones are gonna be 0 0 1 2 to the staying to the left part of the I, 2 3. So let's calculate the number of n 0 ones staying to the left part of the I. So in case it's 0 here, so initial is going to be 0. In case it's 0, it means that we cannot like do anything there, like our n or ones should end with ones, not zeros. So oh, like I should check on this one. So here here you have 0 staying in this position, so it means that I should carry over whatever number of n01s we have from the previous position. So it was 0. Next position we have, next I, we have 1. So it means that I need to use whatever, or I can use whatever n01s I have from the previous position, plus by introducing these ones and joining them with every zero staying to the left of ones, I can add more O1s to the previous one. So the previous O1 was 0 here, and number of zeros I have here 2, staying to the like 2 here, staying to the left of current I. So the answer should be 0 plus 2, so it should be 2. Use white, so 2. And here again I have 1, so this one will join to the number of zeros we have to the right, to the left, I mean. So we have number of zeros to the left is equal to, and the previous number of n O1s 2, so it's gonna be 4, 2 plus 2. So gonna be 4 here. So 0 here, so it means that we cannot add anything, we can just carry over O1s from the left. So 4 and 1 again. You have 1, so it means that on top of carrying over, you can add more O1s to the carry over. So we need to figure out what number of zeros staying to the left of the 1. So it's like 3. So 4 plus 3 gonna be 7. And the same, let's figure out 1 O zeros gonna be equal. So the situation reversed. So number of O1s, 1 zeros. So if it ends with 0, so initially it's like 0. And if it next ends with 0, I need to figure out what was the ones before. So number of ones was like is 0 before I equals 1. So it's gonna be 0 plus 0, so 0. So next one, 1, so I just carry over 0 from the previous one. The next one, I have 1 again, carry over. And then now I have 4, like 0. So it means that I have carry over plus number of ones staying to the left, number of ones staying to the left, like 2, so like 2 possible combinations. So here, like possible is 0, 1, like this one, link. And the second 0, 1, 0 is like this thing, like this. Yeah, and the next one, number of ones, one O's, 1 zeros. We have 1, so it's just a carry over 2. And then I can extend it like number of 0, 1 O's should be, again I check initially 2, again 2 initial gonna be 0, and then I start like accumulating. So this one is ends with 1, so like an O1O ends with 0, so just carry over. This one again carry over, this one here, so I need to carry over plus whatever number of O1s we have here. So we have 4 O1s staying to the left of the 4, I equals 4, so gonna be 4. So we can use this one and this one, this one and this one, and then second this one and this one and this one and this one. Yeah, and then this one just 1, so it whatever we have to the left, just carry over 4. And then number of 101s gonna be the same algorithm. Initial is gonna be 0, 0, and then in the end, on the I equals 2, we have 1. So 1 should be so here 1 is what? Um, so we need to okay, so that's valid. So we need to count the number of check the number of 1 O's to the left, 1 O's to the left, 0. So 0 here again. So this is the same 0, and then this is 0 carry over, and then this one will generate all the combinations. So like 1 we have, so 0 from the left plus whatever number of 1 O's we have to the left, so it's like 2. So the number is like 6. Let's check if it's the same. 6. Okay, so um, so again, n like for example n01s, it's kind of at I, it's number of all O1s combinations up to index I, or that in array in a range between indexes index in a index range between 0 and I, including. Okay, so I will try to now to program this one. So start from for, let's say I'll have this int say chars posting to char array and equals chars length for int I equals 0, I less than so here I'll have int dp of like n1s equals new int n, and then int n2s and zeros equals new int n again, and then I'll have this int n and 0 1 new int n new int n. Okay, so I can probably do this on n1 and new int n. So actually, what we interested is just this number, not a array. So let me just solve this first. Um, 0 1 0. So for int I less than n I plus plus, if chars at I equals 0, then n zeros I equal so it's if it's I and 0 I minus 1, if I minus 1 less than 0, then 0 or like 1. Um, and plus, and 1 I equals um, just this sum. If else if chars I is equal 1, so I will do this. Okay, then n1 oath I equals, say, 0 ones I equals I minus 1 less than 0, 0, otherwise n I minus 1 and 1 oath I equals 1 if, okay, so this one, so if it enters once, we need to whatever add previous one plus I need to add whatever if I minus 1 less than 0, then 0, otherwise n 1 I minus 1. And the reverse is like here. So if n ends with 1, I need to add this one plus I'm less than 1. Check this one. If it's less than 0, otherwise check n 0 I minus 1. And for this one, just here n 1 0 and then so that's it. And then the final one n 101 and n 101 0 I. equals if, so if it ends with, if it's less than this one, well, that just 0, and otherwise end 101 I minus 1. Actually, I should change the order. Yeah, probably. Yeah, like this. And here, if it's end with 0, so if I minus 1 less than 0, then 0, otherwise n 010 I minus 1 plus whatever number of n if I minus 1 less than 0 than 0, otherwise n 01 I minus 1. And a similar one but reversed gonna be for this case, in case chars I is equal 1. So if it's equal 1, I need to check if it's this one less than 0, then just use the previous one. If it's less than, we'll use the previous one, plus if less than 1, so like 1, oh, and then return in the end, return n101 n minus 1 plus n010 n minus 1. Sounds like this is true. Okay, so let me quickly check if it's right. Okay, let me gamble here. I'll check. I didn't know that they have too long description, too long examples. So okay, long. Okay, whatever. Okay. We can do the long. Actually, I can even save some time, like space. And do like this. Yeah, this one should be better for the memory, but if I gonna save chars at I s char at I else something like this. Hmm. Okay, this one is also a little bit better, but yeah. Okay, that's it. I'm gonna wrap up. I'll treat it as pass, even though I checked the hints. There are kind of extended hints. And they gave me the idea how to solve this problem. Yeah, that's it. Hope that you enjoyed this. Solution is like pretty efficient here, but yeah, it's really smart and great idea how to come up with these patterns and like how to build the more advanced pattern based on the like smaller, less advanced pattern.